I was asked to give a technical presentation. And okay, let's see if you like this. So what I came up with was point clouds to products, tools in ArcGIS Pro to make the most of your point cloud data. Oops, let's see here. Come on. There we go. Okay, so the goals of this presentation, I wanted to start from the point cloud and say, okay, well, what can you do with the new ArcGIS Pro tools? We just saw an amazing presentation by Techie of like, if you have a drone, what can you do, but how do you actually go about making some of those products that she was showing? So, and I wanted to do this from the perspective of the average user, right? Like we've all seen amazing presentations by Esri where they get up with like really amazing data sets and show you all this cool stuff. But great, but that's not the real world, right? Like we all have data, it has problems and there's projection issues and all that kind of stuff. So like what can the average user do with a basic Esri license is where I wanted to go with this. So, and try to answer the questions. Well, how hard is the data to work with? How long does this take? You know, are the products any good? And does this ultimately meet my needs? And ultimately, the questions are, how do we go from data to information? How do we answer questions? You know, point clouds are cool, but you know, what else do you do with them? Like they're there, they look interesting, but how do you get definitive answers? Kind of like what Techie was showing just a few minutes ago about like soil moisture, how they took that data and made quality information about thinning. So, okay, so this presentation is like an absolute ton of screenshots. I don't like doing totally live stuff, so I took lots of screenshots, and I wanted to walk you through what I did with the hopes that you could follow on your own later on. I also am a big fan of comics, so there's a bunch of comic breaks in this, and it also reminds me to occasionally stop and drink water and breathe. Okay, so what products we're going to try to make today? I thought, okay, we've got a point cloud. Let's see if we can make a DEM, you know, from some ground points. Let's see if we can do some streams. Let's see if we can do some contours. Let's try to create some vegetation height. I don't care that much about buildings, but I'm sure many people in the audience do. And then maybe we could try to figure out some sort of post-fire damage doing this as well. And squeeze this all into like, you know, an hour. So, I decided for today to show you off the Magnum fire that's up on the North Kaibab. It was back in 2020. We've got some pre-fire LiDAR data. We have post-fire imagery at 30 centimeter resolution, which is a very common data set that we collect after fires. We exported it from the Metashape software as an LAZ file to make it a little smaller. We also have some post-fire LiDAR data that we can compare this to. And I want to make kind of a general assumption with this presentation that, you know, anything that we can create today using a 30 centimeter imagery, a point cloud created from 30 centimeter imagery, I'm going to make the assumption that you could do a lot better if you had a drone, right? So you saw Techie's stuff like you're going from 30 centimeters to like 3 centimeters kind of thing. So we'll just assume, kind of make that broad assumption. So, but using the 30 centimeter imagery as our test data set today, it'll drastically increase processing time and we can experiment with more things. Okay, quick review of what was the Magnum fire. It's about 70,000 acres. It burned rather aggressively. You can see the daily fire growths up here. One day it literally pushed out 17,845 acres. These two were actually the same run. It just happened in the middle of the night. And so it was actually even more. It was 8, 6, 16, almost 17 as well that day. Very aggressive fire. What we call a landscape level change fire. Here's the soil burn severity map. Everywhere that's red is high severity. And so these are those big runs that shot up and then burned all through the North Kaibab. So heavy change, and this is why we've got a lot of data in the area, because we've been studying this one a lot. Okay, so again, to make this a little more simple, we have imagery across the whole thing. We're going to focus on one piece of imagery, the one that you see up there right now. So we're going to zoom in on that one and try to learn as much as we can about that one area. So what is this one area? Why did I pick this one square out of all the others? Well, it's about 2,700 acres. But we've got a couple different things, right? So there's some fire damage over here. We've got some buildings, we've got some roads, and it's high quality imagery. So we'll zoom in here, and you can see we've got buildings out there that we can kind of play with and see if we can do stuff with. Here's some of that fire damage. You can see that there's a burn area through here, some areas that were only lightly burned. It jumped over the road. So we can look at some of those areas. And you'll see all this stuff again as I go through the presentation and work on these products. I'll keep coming back to these areas so you can kind of see what the data looked like for this. Okay, this area here, it's probably tough to see on the screen, but there's actually quite a deep valley that kind of runs through here. And you can see the fire burned up through the valley and scorched all these trees. I'm going to throw some topo on there so you can actually see that I'm not kidding. There's some actual topo lines in here as well. Okay, so let's get started. Let's try to play with some data. We've got our test area. We know what our goals are. Let's see what we can do with this. So using the Metashape software, this is not a Metashape presentation. I am by no means a Metashape expert, and apparently it's a Russian company, so I'm not sure how much longer we'll actually have access to Metashape software. You know, back in 2020, I worked with GTAC, was the Geospatial Technical and Application Center. I used the defaults and I created the LAZ files. So that's really all I'm going to talk about with the Metashape, but it seemed to produce a high quality product. And it outputted the last file. So I was all excited. I fired up ArcGIS Pro. I went to get my data and I couldn't see it. And I'm like, what happened to my data? So I was like, what's going on? I went and checked. It is there. It's very large. What happened? It turns out right off the bat, ArcGIS Pro does not read LAZ files. And I was like, oh, okay. Well, I didn't know that. Maybe the people in the audience didn't know that, or maybe you did. But I thought I always don't talk about, okay, first step was we have to convert our LAZ format to an LAS format so the Pro can at least read it. So first tool I went looking for was something called, convert LAZ, which doesn't exist. Conveniently, Esri has named it convert LAS. I'm not sure why exactly it's named that. I think the intent is converting to LAS, but either way, it took me a sec to run it down and discovered that convert LAS converts things to an LAS format, and I started working there. Another thing I remembered while I was working on this was, hey, everything that has a hammer like this actually has the batch command. And so if you right click on that, the little thing pops up and you can batch control everything. So, okay, wait, hold on here. Keep going. Okay, so if you've never used the batch command, this little window interface pops up and asks you, is this a temporary or a current one or one you want to save? I always do temporary. And then it drops you into the actual convert LAS tool. So you can go out, you grab all your LAS files that you're interested in, you run them through the tool. One of the problems you're going to run into right off the bat, though, is that since you can't actually see your LAS data, if it's, you may need to bring a couple in if you're not going to do the whole data set. I sort of had to fish for the right spots so that I could find the ones that covered my area. So it took a little playing, importing a couple of times till I found the ones I wanted, and then I brought those in. Again, I use the defaults. You're going to hear that a lot in this presentation. I use the defaults just to kind of see what would happen. The only thing on this screen that I changed is I chose to call the point format a 0, okay? Now there's a whole bunch of different types here. I haven't played with a lot of them. I was thinking at the end of this, I would probably try to go back and do something more with bringing in the RGB values. But to start with, I said, okay, let's just do the defaults. And I named everything as 0, which is the base type for storing. So I brought in everything as a 0. So if any of you have been doing GIS for a while, you know anytime you do this, immediately all of your data sets cross the worst possible spot. So these are my 4 data sets that cover our area, and I managed to need all 4 of them. So God forbid it all landed on one tile. So, okay, so I had to bring all 4 in. And I always like to run in and check these things. So I immediately, once I brought in the data, I zoomed in. I'm like, do I actually have data? Did I do this right? And sure enough, look, points. Cool. Awesome. So we actually have some data to work with. I was kind of nervous up to this point, like, so I'm not a Metashape expert, that I would have absolutely no data at this point. So, but we have data, so we can do something with it. So back to our spot here. Okay, we have 4 tiles, but unfortunately, a lot of the tools only allow for 1 input. And we only want to deal with just this imagery right here, right? We don't really want to play with all this other stuff. We want to cut this down. So again, went to the toolbox. Okay, what do we have? Turns out there's a great tool called Extract LAS. All right, cool. Creates a new LAS file from point cloud data in a LAS data set or point cloud scene area. All right, that sounds perfect. Let's give that a shot. So it'll clip out exactly the area you need. So I said, okay, that sounds good. Let's give that a shot. But you can't just drop each individual one in. You can't say, here's my 4 data sets, please clip it. You have to first create what's called a LAS data set, which is essentially a small little file that points at all the others for you. It doesn't actually create new data. So you input all your files, you give it a name, and basically you hit run, and you immediately are given a LAS data set. Now, I don't have a screenshot of this because it literally looks exactly the same as all the others, right? It's still just 4 red boxes at this point. But here's our 4 LAS data sets here, and now we've created what I call the magnifier subset. So all of these are now working together. So now I can go back to our area. I used my personal favorite Esri tool, create layer from selected feature, speeds up everything much faster. Grabbed the tile that we needed for our imagery and used that to clip out our data. So magnifier high subset. I called it my imagery subset data set. I dropped in my digital ortho quarter quad tile index, and we managed to clip out the data, which is cool. So, all right, so we now have gotten down to the area that we're actually interested in. Interestingly enough, it kept the quads, right? So it's got the 4 pieces to it. It kept it separate. So I ended up with 4 different files, but they're all now clipped down for me. Okay, cool, sure, doesn't seem to affect anything. Let's go with it. Okay, but what did we actually do to the data, right? So here is the original LAS files that we imported, and you can see here that 2.2 here was 5 million kilobytes, whereas once I cut it down, it dropped it to 341. So that's a big deal, right? Cutting down your data will increase your processing time and allow you to work only with the area that you're most interested in. So definitely a step worth doing. And as a side note, this is the data you downloaded. For those of you out there who took the time to download the data and were interested in playing with it, this is what we provided you, a nice clipped LAS file full area. So, okay. So I wanted to now start exploring my data, learn more about it, what's going on there. And so I discovered a tool called the LAS point statistics by area. Evaluates the statistics of LAS points in the overlay area defined by a polygon. All right, cool. That sounds great. It'll tell me my lowest value, my highest value, the average, a point count, and a standard deviation. But okay, that's cool. Let's run that. So it's a pretty simple tool. You bring it up, you drop in your LAS data set. You do have to define your project area. So I took the time to take my selected, create layer from selected feature and convert that to a project area. I figured I was going to use it a bunch more times, so I took the time to do that. So we ran that. Now, it's time to talk about my dog, because this is important. So this is Phil, and I discovered that Phil is a great measurement of time. So Phil gets very excited when my computer is doing lots and lots of work because now I'm bored and I have time to go play with Phil. And then this is Phil when Mark is writing emails. He looks very sad and waits for me. So I found that a useful way of talking about tools was like, is Phil happy or sad during these tools? So this one was kind of a middle one, right? So I got to pet Phil and play with his ears and stuff like that, but overall, this tool ran fairly quickly. Okay, so what did we learn? Well, it kicked out Zin, min, max, mean, standard deviation. I learned that even my small area with 30 centimeter resolution imagery still generated 87 million points. It's a lot of points. So you can only imagine what a data set like with what Techie is playing with is generating, millions and millions of points kind of thing. So kind of keep that in mind when you're sort of starting to try to cut some of this data down. I also saw that the min was 7,576 feet for elevation, and the other one was the highest was 8,210. Okay, does that make any sense though? Like, is my data actually good? So I jumped back to that quick topo shot I showed you, and I was like, okay, well, 7,880 and 7,720. Okay, that makes sense. That I think my data is in the right area. Again, I like to stop and do those checks. Like, does my data make sense before I go too far? So that was definitely a tool worth running to sort of make me feel better. Okay, this is LiDAR. Where's the cool 3D stuff, right? Like, statistics are fun, but like, you're all here to see cool things, right? So I apologize, people were trying to contact me, even though I told them not to. Okay, so where's the cool 3D stuff? So here's a spot you're going to see a lot. There's a little bit of a pond. There's some structures. What can we create? Cool. 3D data. Sweet. We see trees. We see buildings. We see all sorts of things. Okay, again, I feel better. We can actually visualize some stuff. Let's look around and see what else we can see. Here's that valley I was talking about, right? So let's see what that looks like. Ah, cool. All right, again, trees. And on top of that, here we have this burned all through here, and so there's a nice little burned area up here with some trees next to it. We can even see that, right? We've seen the area burn here. There's sort of what's left still in the area. We can see trees in the background. I feel good about this, right? Like, okay, I feel like the LiDAR is showing us what it needs to. Now, I'm not an expert in 3D stuff, so there's some elevation issues I'm still working on with this kind of stuff, but this is using like the national globe that Esri provides, so I'm guessing my elevation data is probably a little better. So, but we'll deal with that. Okay, so now let's play with some more stuff here. So now we want to make that DEM, right? When we're talking about products that we want to create, how do I go about making a DEM from this stuff? So there's the classify last ground. Okay, that looks cool. Let's give that a shot. You bring up the tool, you drop in your data set. You have some options with, ground detection. There's like aggressive, standard, and conservative. I'm kind of a middle of the road kind of guy. I went with the standard classification and figured, let's see what this does. So again, Phil was fairly bored. This ran pretty quick. He was not super excited. Just to step back to talk about LiDAR data for a sec, or point clouds, what we're doing is we're classifying those points. And so this is a screenshot of what is a much longer list of things, but these are the most common ones. So right now, all of our data is sitting at 0, okay? And so we want to start getting it into these different categories. And what we're after right now is classifying everything into the ground category, okay? So there it is. I even highlighted it for you. Okay, so here's that structure we were looking at. There's the trees, and there's all of our data. So the brown ones, and I didn't pick the colors, this is like the Esri default, all the brown ones are the ground, and then all the gray here is these unclassified still. So that looks pretty good to me, right? It seems to have done a good job going through, finding all the different holes and classifying the ground area for us. All right, very cool. Let's move on from there. So, and some other areas, just as some examples. So here's a fire area. So we can see areas been burned heavily in here and not so much over here. And so you can see a lot more brown, a lot more ground is occurring in here, and a lot more tree vegetation there. So I feel like the standard classification for ground worked very well, and it ran fairly quickly for the area we're working on. Okay, so I got excited. Let's move on. Let's classify some more stuff. Foreshadowing, this all went horribly wrong next. Okay, so classifying last buildings. Let's do that. There's buildings out there. I'm sure it'll be fine. Again, we're after this category 6 here, right? So that's what we want to do. So let's load that in. We're going to use the classify last building. Kind of similar. You drop in your data sets. Now, it occurred to me at this point when I was reviewing why this one went horribly wrong. I don't really know anything about my rooftop heights that are out there. I don't know anything about minimum areas. I did click the Use Photogrammetric Data button. That seemed like appropriate. So I went ahead and did that. So back to our little test subject. I'm sure all those buildings will come in perfectly with no problems. And they didn't. So apparently there are a lot of like tree houses on the Kaibab. So, because this is what we got. Lots of little areas classifying in as buildings, and that's not true. This is really the only building, and there's a couple others over here that got missed. So the tool didn't work for me, and I was like, oh God, what do I do now? So one thing that I didn't point out, to go back, there's this warning from Esri. This tool modifies the input last data set, which really should say, warning, you're about to hose your data. And you have to figure out a way to undo that. So I then had to find the undo tool, which for this is called the change last class codes. And so what it does is it allows you to go in and say, hey, everything that was a 6, make that a 1 and undo the mistake I just made. Important one to take note of. So we're back to where we were. I undid the damage that I did to my data set. So I didn't have to back up all the way. I did, before I started running a lot of these things, back up my data, so if something did go horribly wrong, I could fix it. Okay, so then I said, you know what? I'm with the Forest Service. We're going to trees. Forget the buildings. We'll come back to those later. So I want to try the classify last by height data set, and we had low, medium, and high. So I said, okay, let's give that a shot. Now, unfortunately, I didn't really know a lot about my trees out there. It lets you break them into 3 different categories. You can adjust these categories to 5, 25, and 50. And what it is anything that's between 5 and 25 will go into the middle one, and then 25 to 50 will be the high one kind of thing. So, and what it does is it looks at the ground points around. You have to have your ground data done first, and then calculates the heights and classifies the data accordingly. This tool made Phil very happy. We went out and played ball and all that kind of stuff while this was running. It does take a while, but I was pretty happy with the results. So all of a sudden, I've got low and moderate and even some high data out there. Well, that's cool. That's awesome. Now you'll notice my buildings are still a problem over here, but I was really happy with how the trees came out. And I think this is a data set that'll be very useful going forward. Okay, so now to go back and fix the building problem, I gave up on their building tool, and they have another one called set last class codes using features. So all last points that intersect a 2-dimensional extent of the input point lines and polygons, along with any buffers, will be reclassified, which basically means you can take any point line and polygon and use that to classify. So I very quickly, there weren't many buildings out there, as you saw. I very quickly went through, digitized all the buildings, and then just classified everything inside these things as buildings. So I found this to be much easier than trying to use their building extract feature tool, which you saw that I messed up with. Maybe there's better applications for that, but I thought this was very cool. And one of the categories here, you'll notice, is road surfaces. So if you happen to have your roads mapped, you can even buffer those and classify those in your LiDAR data set, or you could, there's rail. And like I said, this list goes on. It's fairly long. So I'm sure there's one for power lines and all sorts of other stuff. So really, you can use your feature data to help classify your LiDAR data, which I think is really helpful. Or not your LiDAR, your point cloud data. There's also a tool, I didn't show it here, but there's one for cleaning the noise of your point cloud. So if a bird happens to be flying through or something like that, you can remove that kind of stuff. There's high and low extreme removal tool as well. Okay, so I reran the stats. This time I threw it in an Excel spreadsheet, but now you can see that all of my data has been classified. So, well, a little bit there's unclassified, but we've now got ground points and low, medium, high, and even buildings. So this is cool. So now we can actually finally get to talking about, next steps. Okay, minor break. So for those of you who have never seen these comics before, these is Pearl Before Swine. It's hysterically funny. I highly recommend it. So, okay. So let's build the DEM. Let's actually start creating some products. So the last data set to raster conversion is a cool tool. It basically takes your point cloud data and turns it into a raster. So the first thing I did, I got all excited. I put the data in, and I called for elevation, and I ran it. And then I realized something is that what it's doing is it's taking absolutely all of your point data and turning it into the raster. So it doesn't really create a DEM because now all your trees and buildings and stuff are all in the way. And so what you actually first need to do is pull out the data sets that you want. So remember, we took the time, we classified everything nicely. So now we can start pulling those out and extracting them. So there's another tool called the Make Last Dataset Layer, which allows you to just go in and pick the one you want. So since we're making a DEM, we check the number box, the number 2 box there, and we run that, and it creates for us, it pulls out rather all of our ground data. Okay. Now, this was cool, but I then started wondering, well, what am I left with? How do I know what our data set is doing? So I found another tool called the Last Point Statistics as Raster tool. And this is interesting because it basically, you can throw in a last data set and visualize various things about that. So for this, I did point count, and I dropped my cell size to 1. So I asked the question, how many points per square meter do I have in the data set? So it created a visual for me, which is cool. So now I can see in these open fields, how many points am I getting? And for most places, it's 3 to 5 points per square meter. There's a couple areas where it really sort of spikes up, and then there's other areas that are completely empty. But I found this to be a really helpful tool for helping me understand what's actually out there. And I found this to be more helpful than just looking at a bunch of dots on the screen, right? So, okay. So now we're ready, right? We've got our ground points separated out. We throw that into the last data set raster tool. We ask it to do the elevations. We give it a fancy name. And then also you can then select the sample size, right? So your cell size is what your sampling type, and then your sample size is essentially your meters. So I started off with a 10-meter one. I'm assuming that looks fairly blurry on your side too. You know, there's the pond right there that you can kind of sort of see, and there's the shed that we've been looking at. And then we can step through. I did one for 5, and then I did one for 3, and then I finally made a 1-meter DEM. And that looks pretty good, right? Like I can see some sort of fencing right there. I can see the shed. I can see the pond. This worked really well, or at least I think it did. There's actually a problem that your eyes may not be picking up, which is that if we zoom in and bring back our raster statistics, you can see that it's actually filling in those gaps. And so that's a decision you're going to have to think about, like how much gap is occurring when you create your DEM and how are you filling that void. So when we go back to the tool, there was actually a void fill method. And what I used is the default. Again, we're very default here. And so I chose the linear, which triangulates across the void areas and uses linear interpolation, blah, blah, blah. And I thought, okay, well, that sounds cool. So, but it's not right or wrong. It just simply is what the tool does. And I felt pretty confident using that, so to fill in those voids. But you can also use simple or a natural neighbor or none. And the none is an interesting one that at first I thought, well, why would anyone use none? But when we get to the vegetation stuff, I'm going to come back to that. And I think there's some interesting applications to using the none option. So, okay. So all the way back to the beginning, what are the products that we're interested in? I feel like we've made a good DEM. Okay, so we've got our DEM. We accepted that we're filling in some gaps. And now what can we do? I started to play around with streams, and then I remembered that streams are actually really hard to do. They're not impossible. I think there's a bunch of tools that you have to go through, and there's flow directions and all that kind of stuff. So I didn't bother to do streams quite for this presentation. I didn't have enough time, but I feel confident that the DEM that we created could have made streams if I had a little more time to create all that stuff. I did take the time to make contours though, and that came out pretty cool. So there's our contour data set, right? And I thought that was pretty impressive. Now, obviously, these contours need to be cleaned up because when you immediately use the contour tool, you have little problems and little circles. But like it called out the pond, and there's that valley that I've been showing you over and over again. So I think we've succeeded in making contours. I feel like we've made a really solid DEM. Okay. So, small break. Okay. I know, you're thinking you're going to go out and buy a cardboard box next, I can tell. Okay. So, back to the make last data set layer. Okay, so let's go on to vegetation. We're the U.S. Forest Service. We care deeply about this. Let's see what we can do about making like a canopy height model or something like that. So where this time we're going to extract 3, 4, and 5, which are our low, moderate, and high point cloud, right? Using the same make last data set layer. And here it is. Now, I kind of chose to feel that this is kind of shrubs out here. I can't really confirm that. Maybe those all should have been just ground points. But for this, we're going to say, hey, those are all kind of shrubs. And then here's all of our trees. Okay. So this time we have our last all vegetation layer that we just created, right? And we're going to make our DSM veg only layer. We're going to use the elevation points. And we're going to stick to the cell size of 1. And there we go. And that looks pretty cool, right? Like, okay, I see vegetation there. That looks cool. There's trees. You'll notice that our building is cut out, right? Because we took the time to classify that building as a 6. So that got cut out. But because we chose the linear interpretation, it actually filled in that zone. And so just so you can kind of see the difference, there's the old data inputted, and then here's the just the vegetation one. So again, you kind of have to make your own choices here, but that's what I went with. Now, the next thing is the basic equation, right? Vegetation, elevation, height, DSM, minus your DEM gives you canopy height, right? Because all this is really showing us is the elevation of trees, and that's kind of useless, right? Like we want to know how tall those trees are, right? We don't want to know the elevation of those trees. So you have to subtract the elevation height from the ground height to give you your canopy height model, okay? So, slightly different area. Here's our pond. Here's our trees. Not bad, I thought. Okay, cool. That works. That has extracted trees. You know, is it as perfect as my nice, pretty LiDAR data? Probably not. But I think for this tool, for using imagery, I think that's done a pretty good job of tracking where the trees are. I'll just go back and forth for a sec. So you can see some of the smaller ones in here, you know, and those have come through showing us the canopy. So, okay. Let's see here. Okay, so let's go to a few other areas. This is one of the burned areas. So here, lots of black sticking, a lot of destruction, and then there's some vegetation kind of left here in the center. And there we go. It's again extracted so we can sort of start saying, hey, how much vegetation was lost due to this fire kind of thing. It's not perfect, it's not LiDAR data, but I thought it was pretty darn good. Okay, here's another area with some roads and some more vegetation. And there we go. More tree extraction. You can kind of even see kind of individual trees that are out there. So, okay. So that's our vegetation stuff. I feel like that was good. I feel like we made some good progress there. We've conquered contours. We've made a DEM. We conquered contours. We created a vegetation height. Now, I'll go back to buildings. Again, not my favorite thing, but I thought, let's give this one more shot. And I stumbled across the last building multi-patch tool. And I thought, okay, the illustration looks cool. Let's give this a shot. Let's see if we can make something from it. So I sort of followed the defaults. I input the imagery. I input the buildings layer that I created. That's the polygon layer to show where we're doing this. And then I extracted the building classified points. And then you have to identify your ground as well, your ground cells. So I threw that all in there, let it run, and I created buildings. So that's pretty cool. I was happy with this. There's my 3 buildings from the area. And again, going back to my note all the way at the beginning, this, I'm assuming that if you had drone data with really high point clouds, your buildings would look even better. But I found it to be fairly successful. I also threw the plants in the background just for some scale kind of thing so you could see them there. So, but I felt this was good, and I managed to get the buildings to appear on the imagery. So I think building extraction is definitely something with some tweaking you could do better with. Okay, final step, colorizing the last data set. Applies color to the near infrared values or orthomorphic imagery to last points. So basically you take your point cloud and you input RGB values, and then you can sort of colorize it. So interestingly, this was the little thing. I just thought this was really funny. Displays last points using RGB information, can provide an immersive, photorealistic display that delivers a unique display experience. I just thought that was kind of funny. They wrote that in the stuff. So, okay, so let's try to make a unique display experience. So there's the colorize last tool. You drop in your imagery subset. We're going to use all of the data for this one. I dropped in the imagery. This is the tile that we're working with. And then I identified blue, green, red, and near infrared. Okay. So there we go. The completely unique display experience. So here we have our trees, we have our buildings, we have our pond. I think it came along really well. And so I've colorized it for near infrared, but I think this was kind of worthwhile and interesting to do. Let's jump over to, oh, before I go, you can also, just while you're in the 3D mode, you can also say, show me the data via the classification you've created. So here you can see in a 3D sense, the ground points, the shrubs, the trees, and then our buildings there. Okay, so let's look at this area. This is pretty cool. This is now telling us some fire data, right? You can see, you can now visualize the burn scar, right, in 3D. So, and you can see the differences in the tree heights. So I think there's some definite value in here as well. Here's another fire scar that you can kind of see up here as well. And then the trees that survived over here. So, okay, how am I doing on time here? Oh, I'm a little faster than I thought I would be. Okay, so goals of the presentation, right? So starting from the point cloud, what can we do from the perspective of the average user? Let's look at these questions and sort of talk them through. How hard is the data to work with? It was actually fairly good. I had a good experience with this. I felt like the data worked well. The tools I came across worked in a good path. And I found a lot of the Esri documentation pointed me back to any other tools that might help me. So like if I got to like the vegetation height classification, it would say, hey, you need to have the ground points classified first. It would link you to that one. So I found that good. How long did it take? It's tough for me to say. I was sort of stumbling through the dark, but I think if you guys went and took my PowerPoint presentation and were like, hey, I want to see all these tools, I think you'd have a fairly good experience. It wouldn't take too long depending upon the size of your data set. How good are the products? Well, it depends on the data, but I gotta say I felt very happy with the 30 centimeter Metashape software derived point cloud. I felt like I got some really good products out of this that I could do a lot of analysis with. And did it meet my needs? Yes, I felt so. I felt like we're on a good path here. So, okay, so some takeaways from all of this. I hope this has given you the confidence to go explore the LAS toolkit. I think this is you know, something that I had never touched before prior to this presentation. I am kind of blessed in that I'm with the U.S. Forest Service, and I think Tom Mellon is still on the call somewhere. Tom is our regional remote sensing coordinator. A lot of the heavy lifting I don't have to do. I call Tom and I'm like, hey, Tom, I'd really like a 𝐀𝐫𝐢𝐳 model from my LiDAR data. And Tom says, sure. And like a week later, this amazing data set shows up. So that's why I wanted to do this from the user perspective of like, what can the LAS toolkit do for me? What is it like interacting with these? And I found it good. I found the Esri documentation good. And I would definitely encourage anybody to explore this. And turning your point clouds into products, I also think this was really helpful. I know kind of prior to this, I tend to work with the LiDAR derivatives. I felt like this gave me a really good depth into understanding point clouds, not being afraid of them and saying, okay, let me go try to do something with these, and feeling that the tools were very helpful. So I would definitely do that. Some other steps that I didn't get to this that I thought were to talk about is starting to compare these things. I didn't have a chance yet to go look at pre-fire LiDAR data or my post-fire LiDAR data and see how this matches up. That'll probably be something I do in the future, and maybe I'll present that on one of the LiDAR calls at some point. The other thing, and I didn't list it here because it actually came up yesterday, was going all the way back to where I talked about that no data void. And I started thinking, interesting. What if I only created a last data set of the low vegetation and I chose the no data set tool? All of a sudden, that would create a DSM of just the low vegetation or the moderate or the high. Would that be interesting? Would it be a way of calling out rangeland data or just, you know, fences or something like that, or extracting specific band layers of LiDAR data. And I think there's some interesting applications that we'd like to explore with that further. Or you could in turn cut it and say, hey, I want to see the canopy height 18 meters and above. I only want to see trees that are big. I only want to see, trees that are 50 meters and above, or something like that. It would allow you to extract canopy covers from the point cloud based on various heights. And I thought that was interesting and worth exploring. The last thing is I didn't get to your streams, and I apologize for that. But streams are kind of a pain because they have to flow in the proper direction, so I didn't get to those. But that would be the other thing that I would go after. Okay, and once again, you get to see Phil because Phil is awesome, and here's Phil at the beach. I really appreciate your time, and I'm definitely open for some questions. So,
nice job. That's awesome. So I want to remind everyone, when you registered, there was an option to access. So you should have received an email from me. Hello. Mark, there was a comment in the chat about sharing your workflow. And what's your suggestion for that? You had mentioned that folks could go back through your slides. I make those available. Is that going to be the easiest way?
I think so. I'll probably have to pull out the comics for licensing reasons, but I would be happy to make this. It's kind of how I designed this from the beginning, was to lots of screenshots, so that you guys could specifically see the tool that I was using when I'm talking about different areas. And you would have the title so that you could very easily find it in the Esri documentation. So I don't know how we're planning on sharing all the presentations. I'm sure we'll figure that out. But
yeah, that's my job. I'll show them. Everyone will get a copy. So thank you. Definitely adjust them as you need to.
Maybe pull out the photos of Phil. So.
No, we want the photos of Phil to stay in. So I don't see any questions from folks online. Do we have any questions from the folks in the room?
Is it typical to fly a Forest Service LiDAR mission post-fire? I'm thinking Telegraph and Bush in Gila County.
Do you hear that, Mark?
Yeah, so no. Let me pop up so you guys can see me a little better. So no, the only current standard right now is to fly imagery, which is kind of why we wanted to explore this. It's almost every year toward the end of the fire season, we get an email saying, what fires do you want? And so we usually fly somewhere around a 30-centimeter resolution of imagery. And side note, those are now actually the last round as a new experiment. They're all now publicly available. So that was Raphael. I forget what the others were. There was another couple big ones down in the Tonto and around. So, but yeah, we always find money to fly everything. The Mangum fire was the first time, as far as I know, in the country that we collected LiDAR data post-fire. But based on that, GTAC actually worked with the state of California, and they actually I think are in the process of flying LiDAR data for a lot of the California fires now too. So it's gaining some momentum, I'm thinking. We have spent a lot of time debating the value of post-fire LiDAR data because trees take time to fall over. So is it better to get post-fire LiDAR data like 5 years later or 10 years later? Or do we do one immediately after and then get it 5 and 10 and 15 years? We haven't quite figured out what that cycle is because I think it's still a fairly new technology, but it's something we're starting to explore. And LiDAR or point clouds taps us into structure. Prior to this, we're very good at doing monitoring trends in burn severity, MTBS, which gives you that high, medium, and low severity, but it doesn't tell you anything about structure. It doesn't tell you if the tree fell over. And so that's something that we want to explore a lot more, and LiDAR gets us there, or point clouds may also get us there as well. Structure for motion, rather. So we're still trying to kind of figure that out. But definitely Right now, for the last couple of years, all the main fires have post-fire imagery available.
So there was one comment in the chat about including your notes in your slides. So if you haven't, please do.
I don't really have notes, but I'll try.
Excellent. I don't see any other questions in the room, and I don't see any in the chat. So thank you very much. Excellent.
Cool. I hope this was helpful for people. I tried to, my goal was that folks would be able to follow in these footsteps and maybe explore some of these new tools. So